Hello friends, this is the seventh lecture of unit alcohols and phenols, and we were discussing various methods by which we can produce alcohols. So in our previous lecture we discussed how alcohols can be obtained by reduction of acids. When I write acids it means carboxylic acids and esters. We basically discussed the reduction with the lithium aluminium hydride. Today we will discuss a yet another method by which we can synthesize alcohols from esters. This is a typical reactions of ester, and the name of this reaction that we will discuss today is Bouveault Blanc reduction. This is a typical reaction for the reduction of esters to alcohol. So let us start. First let us learn what is a Bouveault Blanc reduction. So what are the reagents required in this reaction? In this reaction ester we can denote like this: RC double bond O OR dash. It is reduced in the with the catalyst sodium, and it is not catalyst, it is a reducing agent, sodium and ethanol, and we get two alcohols. The product is first alcohol from this part are CH2OH primary alcohol plus second alcohol from this part R dash OH, and reducing agent is sodium in the presence of ethanol. So this reduction is also called dissolving metal reduction. Dissolving metal reduction, and it is similar to Birch reduction. There is a reduction similar to this called Birch reduction. We will discuss someday other about Birch reduction. So it is similar to Birch reduction. Second important point is that in this reaction sodium act as one electron reducing agent. So we know that sodium 0, that means metallic sodium, it can give sodium positive plus electron. So sodium is the source of electrons, and addition of electron is also called reduction. Another definition of reduction is addition of electron. And this ethanol, third is ethanol. Ethanol, the role of ethanol is it acts as proton donor. So these are the various functions for sodium. Sodium acts as a electron donor. We can say it is one electron reducing agent because it gives one electron. And C2H5, it acts as a proton donor, H positive, and this reduction is also called dissolving metal reduction. So let us write some reaction to give. We can write any ester CH3 CH2 CH2 CO O C2 H5. If we reduce it with sodium and ethanol, then what will happen? As I already told you that first it will give two alcohols. First product from this part will give you CH3 CH2 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 OH, whereas this part this part it will give you plus C2H5OH. So we will get these two alcohols if we do the reduction of any ester with sodium and ethanol, and this reaction is called Bouveault Blanc reduction. So basically this reaction involves the mechanism of this reaction that we will discuss in our next slide. It involves addition of electron and proton. So subsequently, once we add electron, then we add proton. We will see in the next slide when we will discuss the mechanism of the reaction. Another important point is, as we know that sodium is highly sensitive to moisture. It may also catch fire in moisture. So the ethanol that is used in this reaction, it has to be dry. Dry means it has to be free from any moisture, otherwise sodium will react with the moisture and it may catch fire. So now let us, so this is the all about the reaction, what it is all about. Now let us quickly discuss the mechanism of this reaction. So I will first write the equation. We will use general reactant RCO OR dash in the presence of sodium and ethanol. It gives you RCH2OH plus R dash OH. So this is the reaction. Now we will see what is the mechanism of this reaction. Mechanism, as I said from our previous slide, sodium is one electron donor, C2H5OH is a proton donor. So these points you have to keep in mind when we will discuss the mechanism. Overall, the mechanism involves subsequent, it is quite simple, subsequent addition of electron and proton. Means first we add electron, then proton, then add electron, then add proton, until and unless we get these desired products. So we will keep on adding electron and proton. So let us see, let us write the first step. In first step, what will happen is that R C double bond O, we write like this, O R dash. First step is addition of electron. Now this electron comes from sodium, okay, plus electron. Now what we can do is this bond, it is a free radical. If we do its homolytic cleavage, what will happen, this electron will go here. When we have to move one electron, we do it with the help of a single arrow, and one electron will go to this. So what we get if we do its homolytic cleavage, what we will get is, we can write it as R C radical O R dash O, two electron and one electron more. Now if we add electron to this species, what will happen now, as oxygen is more electronegative than oxygen, so oxygen is more it is electronegative than carbon. So this electron that we will add, it will add to this oxygen. So what we will get, we will get a product something like this, R C O O, one electron is added to oxygen. This electron, this goes to oxygen. Okay, we get this. Here we have a radical O R dash. Now in doing so, oxygen will acquire a negative charge. So we will get this structure. In the next step, what we will do, we will add a proton. As I said, this reaction involves subsequent addition of electron and proton. Now proton will add to O negative, it will go here and we will get something like this, R C O H O R dash, this radical. Now in the next step, we will add one more electron plus electron. So what we will get is that we get R C OH. Now this electron will go to this carbon so that it can, because radicals are very reactive, so OR dash 2 electrons, and in doing so it will acquire a negative charge. So in the next step, as I said, it will be addition of proton, subsequent addition of proton. So now this proton will go to this carbon, so we will get R C O H O R dash C H. So we can also write this something like, we can show this bond OH. Now why I have shown like this, because we have to produce R dash OH. Now in this step R dash OH will be produced, so it will be produced like this electron will go here, it will go here, so it produces H positive, it produces R dash O negative. So this H positive it goes to oxygen and minus R dash OH, this alcohol is liberated. So here is the alcohol. In this step R dash OH is formed like this electron, I will show, it is not clear, this electron will come here, this bond will shift here, so we will get R dash OH. Now if we remove this electron, what we will get? H positive plus, now if we add electrons to oxygen, what we will get? R dash O negative. Now these two will combine to give you minus R dash OH. Now what is left? The left is R C double bond OH. So we get aldehyde. So aldehyde is formed, but the product is alcohol. That means we further have to add electrons and protons. So next step, as you can guess, it will be the addition of electron. Now this electron will add to C double bond O in a similar way as this. So what we will get? We will get, I will show once again for your clarification. So it is the same step that we have done earlier. This electron will come here. Now electron will go to oxygen. So what we will get? We get what? R C O negative H C radical. Next step, as you can guess, it is the addition of proton plus proton. So what we get? We get is R, this proton will add to oxygen, R C O H C radical H. Next step, you can guess easily, it is again addition of electron. So this mechanism is quite simple. We keep on adding electron proton, electron proton, electron proton until and unless we get our desired product. So we, now this electron will go to this carbon, but we will get R C O H H C negative. Now once again we will add proton. So this proton will go to this carbon. So what we will get? R C O H H H. So this is equivalent to R CH2OH. So we get this alcohol, R CH2OH. So overall the products are, if we have to write, we get two products, R CH2OH plus once we have also got this R dash OH, it was liberated in this step, plus R dash OH. So these are two products that are obtained. As you can see from our reaction, we have to get two alcohol. So this is the overall mechanism of this reaction. So students, it is quite simple. You should be little bit logical how to add electrons. So first show homolytic cleavage here. So we can write it like one electron to oxygen, one electron to carbon. Now if we add electron, as oxygen is more electronegative, this electron will first go to oxygen. So we will get this After this, when we will add proton, proton will add to O negative, you will get this. Now again electron, electron will go to this electron, so that these radical can combine with another electron, because radicals are unstable. So you get this type of carbonyl like structure because negative charge is on carbon. Next step is addition of proton, you will get this. Now this step, it's little bit, now this step is different from other steps, because in this step we have to release R dash OH, because it is formed in the products. So what will happen is that this electron will come here, this will come here, so you get R dash OH and this aldehyde. Now reduction of aldehyde is again similar to the reduction of ester, addition of electron, proton, electron, proton. Now if we count how many electrons we have added, 1, 2, 3 and 4 electrons. So 4 electrons means we require, for this reaction we require 4 equivalents of sodium. Why? Because we need 4 electrons. So that is the overall mechanism of this reaction. This is similar to another reduction which is known by the name Birch reduction. That mechanism is also similar to this one. So this is a general mechanism for reactions involving electron and proton. So whenever you will encounter a reaction in which electron and protons are involved, the mechanism will be similar to like this scheme that we have done. So that was all for today. So today we did a very important and simple reaction of reduction of ester, and this reaction goes by the name Bouveault Blanc reduction. And in this reaction the reducing agent that is used is sodium and ethanol. Sodium acts as source of electron, whereas ethanol acts as source of proton. So the mechanism involves subsequent addition of electron and proton until we get alcohols. So we successfully explained the mechanism of this reaction also. So this is very important and very easy reaction that we have done today. So that was all for today. In our next lecture we will see how we can synthesize alcohols using organometallic reagents, organometallics, like most probably we will discuss the example of Grignard reagent RMgX. This we will discuss in our next lecture. So if you like the lecture, please do subscribe and also share with other students, so that maximum number of students can be benefited from this lecture. Thank you very much for your kind attention. Stay blessed.